Hi, this is the next video for functions. So we are continuing to look at modulus functions. For this video, we're going to look at how to combine graph transformations with modulus functions. So how to sketch a modulus function and then transform it. Now you have done graph transformations in year one, and I have extended slightly and looked at two possible transformations. I think in a couple of examples of questions that we've done there has been two transformations, but actually you can have 2, 3, 4 transformations that are all happening to a function, and you need to understand the order in which they happen. So here are the basic rules. So just to remind you, you've got two translations. So if there is a constant that's been added or subtracted, then you have got a translation. If there is a multiple of a negative, then that's a reflection. And then if there is a multiple of a constant, then that is a stretch. And just to remind you that if the transformation notation goes into the function, so if the algebra is adapted by it going into the function, then that's going to affect the x coordinates. And generally, it does the opposite of what you think it's going to do because it's in the brackets. So if it's got x plus a, then it's going to move left a. So if it says x plus 2, it would move left 2. If it said x minus 2, it would move right 2. If it was f of 2x, then that would be a stretch scale factor of half. If it was f of a quarter x, that would be a stretch scale factor 4. So it's doing the inverse. So in brackets, think of it as an inverse operation. F of minus x is affecting the x coordinates, which means it gets reflected in the y-axis. All the ones that are happening outside of the function notation, so it's happening to the whole function, that affects the y-coordinates in the way you would expect it to. So, what I would like you to do is write down the graph transformations that act on the function y equals f of x. Now you can see for each one, there's 2 things happening. This one, there's 1, 2, 4 things happening. So there's multiple transformations. You need to know the order in which they happen. Generally, rule of thumb is that you're going to follow BIDMAS. So if there are brackets, then that happens first. There won't be a power, but there might be a division. There's going to be a multiplication. There might be an addition or subtraction. Okay, so generally you are going to follow BIDMAS. The only exception is if there are more than 2 things in the bracket, then you are going to consider it as inverse operations, like you're solving an equation. Okay, so I would like you to write down the transformations. Remember, you've got to use key wording. So if it's a reflection, you need to say that it's a reflection, and you need to say what axis it's reflected in. If it's a translation, you need to state that it's a translation and then give a direction, either verbalise it or use a column vector. If it's a stretch, you need to say it's a stretch, you need to give a scale factor, and you need to say which direction it's in. Okay, so pause the video and I'll go through the answers in a second. Okay, so the first one, you've got a bracket and a subtract. So the brackets first, so that's a translation left 2, followed by a translation down 3. Or you could say it's a translation with a column vector -2, -3. This one, brackets first, followed by an addition. So the brackets, this is a stretch, scale factor 1/2 in the x direction, followed by a translation up 4 or 0,4. This one, you've got a bracket and you've got multiplying by a -1, if you like. Bracket first, that's a translation, 5 to the right or 5, 0. And then the minus is acting outside of the function, so that's affecting the y coordinates, which means it's a reflection of the x-axis. Now this one, there are 2 things in the bracket. If you've got things in the bracket, then you are doing inverse operations. And you need to consider it like you would solve an equation. If you were doing 3x minus 1 equals 5, the first thing you would undo is that, and then you would undo that. So it's the same approach here. Actually, the first thing that's going to be done to the graph is it's going to move to the right 1. So you've got a translation to the right 1 or 1, 0. And then you've got a stretch, scale factor 1/3 in the x direction. This one, bracket first, so you've got a reflection, so it's a reflection of the y-axis, followed by a stretch, scale factor 3 in the y direction this time. So this one's affecting the y because it's on the outside. This one, lots of things going on. Brackets, then you've got multiplications, then you've got this subtract. So first thing is first is this. So that's a stretch, scale factor 1/5 in the x direction. Then you've got 2 multiplications, and it doesn't actually matter, just like if you're timesing something by 2 and then 3, it doesn't matter if you do by 3 and then 2. So you've got a stretch, scale factor 2 in the y direction and a reflection of the x-axis. So it wouldn't matter which way around you did that. Then you've got a translation 3 down. This one, 2 things inside the bracket. So again, like number 4, this is going to happen first. So it's going to be a translation left 3, followed by a stretch, scale factor 1/2 in the x direction, followed by a stretch, scale factor 4 in the y direction. And then the last one, again, you've got brackets. Again, you've got 2 things that are multiplied, so it doesn't actually matter which way round you did it. Scale factor, stretch scale factor 1/2 in the x direction and a reflection of the y-axis. Wouldn't matter which way around you did it. Okay, so there's multiple things going on. Generally follow BIDMAS unless you've got 2 things inside the bracket. And then you're considering inverse operations. Okay, so how does that apply to modulus graphs? It says, tip, carry out the process in stages if there is more than one transformation. Now you're not going to, at any point, have to transform a modulus graph that doesn't start off life as a linear. I've not seen any questions where you've got to sketch a modulus quadratic graph and then transform that. It always starts off as a linear. Okay, so 2 examples. So what you need to do, if you look, you've got some modulus graph that's then had something done to it. So what you need to do is consider this, the modulus part, as your baseline. So sketch that first and then adapt it. And if need be, draw 3 different diagrams. Because obviously you're going to have to think about what this looks like to begin with before you even do anything. Okay, so modulus x plus 1. So x plus, first of all, what does x plus 1 look like? X plus 1 goes down, gradient 1, through 1, like that. Okay, modulus x plus 1 goes down to the x-axis, but then where it's the bit below the x-axis gets reflected back up in the x-axis. So that's modulus x plus 1. Then there is a 2 outside it. So if this is our baseline, there is a 2 outside of that. So it's multiplying the whole thing. And then there is a plus 3. So this is a stretch scale factor 2 in the y direction, followed by a translation up 3. Now let's just think about what we've got so far. We've got modulus x plus 1, so that there is 1. And this is minus 1. If we stretch that with a scale factor of 2, this it's affecting the y coordinates, so where y is 0 here is going to be unaffected, and actually these are just going to end up steeper. So that might end up looking a bit like that, where that is 2. And then that whole thing needs to move up by 3. So I'm going to move it up by 3. That now is at the point 5. So it started up at 1, then it doubled, and then it moved up by 3. So that point there on the y-axis is 5. Okay, so I'm not extending it to make it touch the x-axis. Draw my modulus graph, and then I've adapted it. So we've now got this V shape that looks like it's just floating. Okay, so if need be, what you could do is just do multiple little sketches. So you've got your first one, that's going through 1, and then you might do another little one that's going, another one that's going through 2, and then do your final one. Okay, so don't worry about doing multiple ones if you need to, but just make sure that your final one is clear which your final one is. So that looks like that. Now, lots of questions are going to be based on this. One very useful thing to do every time you do one is write down the vertex, this point here. This point here is the vertex, and the vertex occurs, we think that this is the modulus, so this is always positive or 0. This is the lowest that this is ever going to be is 0. And that occurs when x equals minus 1. When this is 0, then all of this is 0, so the y coordinate will be 3. It's very similar to when you're completing the square. The turning point there will be minus 1, 3. Okay, so it's essentially the same thing. Instead of brackets squared, we've got modulus sign, but it means always positive. Okay, that will come in handy when they ask you questions. You might be expected to give the range of this graph. So the range of this graph, if the lowest value, y value there is a 3, then the range will be greater than or equal to 3. Okay, so they could ask you that, they could ask you various things. They might ask you where another line touches the vertex, etc. Okay, so I would just get into the habit of labeling your vertex, because you're always going to get a straight line part here. It's always going to either be a V that way or an upside down V. Okay, so this next one, 2 minus x minus 1. So again, if you consider first of all just the modulus part, so x minus 1, well, that would come down positive gradient and go through minus 1, like that. So that be at 1, that would be at minus 1. But again, once it hits the x-axis, everything below the x-axis then gets reflected. So if this point here is minus 1, then that point there is 1. And that point there is 1. Because when y is 0, x is 1. Okay, so that looks like that. Now if we think about what's happened, we've got a minus on the outside, we've got minus f of x, and then we've got this 2. Well, that's just the same as that. Okay. Those two things are the same thing. So we've got a minus on the outside of the function notation and a plus 2 on the outside of the function notation. So BIDMAS, do the multiplication first. That's the reflection happens first. So that's actually reflection on the x-axis. So that needs to reflect in the x-axis. So that's now going to look like that. And then the whole, so that's now at minus 1. And then that whole thing is going to move up 2. So if the whole thing moves up 2, just move it up. It's going to look like that. That's going to go through 1 again. So it started off going through 1. Then it reflected, so it went through minus 1, and then I've moved it up 2, so it's gone back through 1 again. The vertex occurs when this is 0, so x will be 1, and if this is 0, 2 minus 0 is 2, so the vertex is at 1, 2. So the range for this graph, if we're asked for the range, f of x has got to be less than or equal to 2, because that's what the maximum y value is. Okay, so again, you could have broken it down into parts. You've got your x minus 1 graph, then you could have reflected it, and then you could have moved it up. Okay, so do however many graphs that you need to do, but make sure that your final answer is clear. Label where it crosses the y-axis. We'll look at where it crosses the x-axis later in this case, and label the vertex. Okay, so you should have these 4 in your booklet. I want you to sketch the graphs, mark on where each one crosses the y-axis, and what the coordinates of the vertex are. Those 4. Okay, we'll go through the answers in the tutorial. Once you've done that, exercise 2F, page 47. Okay, and that's the end of this video.